All right, so here we're going to have a application problem. So we have a computer manufacturing company has two assembly plants, plant A and plant B, and two distribution outlets, one and two. So plant A can assemble at most 700 computers a month and B 900 computers a month. Now outlet one must have at least 500 computers a month and outlet two must have at least 1,000 computers a month. Now, transportation costs for shipping one computer from each plant to each outlet are $6 from A to one, $5 from A to two, $4 from B to one, and $8 from B to two. Now, we're supposed to find a shipping schedule that minimizes the total cost of shipping the computers from assembly plants to the distribution outlets. And what is this minimum cost? All right, so let's first figure out what our variables are. So if we do that, our variables are going to be, let's call them x1, x2, x3, x4, because that's just kind of the convention we've been using. So x1, x2, x3, x4. So let's let x1 be the number of computers shipped from, and now we'll go from A to plant one or outlet one. And X2 B from A to 2, and X3 B from, and X4 B from, and now this will be from B to 1 and from B to 2. Okay. I think that's going to make it the easiest for figuring out what all the X's are here. All right, so the next thing we need to do is to uh, write our equations. So plant A can assemble at most 700. And so if we think about what is part of plant A, well, X1 and X2 have part A. So we can say X1 plus X2 is going to be, has to be at most, has to be less than or equal to 700. And this is again from A. That way we can kind of keep track of what we're doing. Now B has at most 900. So then we can say, well, x3 plus x4 has to be less than or equal to 900. And so let's say that's from B, so we can keep track of that. Now, outlet one must have at least 500 computers. So that means 500, that means this one and this one. So that means we have x1 plus x3. And that has to be at least, so it has to be greater than or equal to 500. And that's outlet one. And then outlet 2 is going to be X2 and X4. And that one has to have 1,000 or greater than 1,000, greater than or equal to 1,000. And that's outlet 2. Okay. Now, the next thing we need is to have some kind of a cost function. So we want to minimize the cost is equal to what? Well, it's going to be 6 times x1 plus 5x2 plus 4x3 plus looks like 8x4. Okay. All right. Now the question is, do we have a problem set up in the normal fashion? Because remember, when we're doing our problems, we get find one, they're always greater than or equal to for our subject two. This one is not all greater than or equal to. Those two are less than. So what do we need to do? Well, this types of applications, what we're going to have to do is we're going to have to multiply this one times the minus one and this one times the minus one. Because remember, when you multiply by a negative, we switch the inequalities, and then we were going to have all greater than or equal to. So let's do that, and we'll put that on the next page. And so once we multiply, let's say our new problem is going to say minimize C is equal to what? 6x1 plus 5x2 plus 4x3 plus 8x4. And we're subject to what? Now, when we multiply that, that's going to give us now a negative x1 minus x2 greater than or equal to a negative 700. I probably better make that negative better there. So it's a negative. And then we also had a negative x3 minus x4 greater than or equal to negative 900. Then the other two stayed the same. X1 plus X3 had to be greater than or equal to 500. And then X2 plus X4 had to be greater than or equal to 1,000. And so here, X1, comma, X2, comma, X3, comma, X4 all had to be greater than or equal to 0. All right. So that really is our starting point. So this all kind of converted all the words to, knowing what the x's were, converting it to this, but then we don't have all of them greater than or equal to. And so now we have a normal minimization problem. So with that in mind, now we can do our A and our A transpose so we can get to our dual problem. Well, what is A? Well, we're just going to go kind of across the way here. So we're going to have -1, -1, 0, 0. And then we're going to have, that one's -700. I don't know if I need to go that far, but that's okay. And then we'll have a 0, a 0, a -1, -1, and that's going to be a -900. And then we'll have a 1, 0, 1, 0, and that has to be the 500. Then we have to have a 0, 1, 0, 1, and that's a 1,000. And then we use our numbers up there, a 6, a 5, a 4, an 8, and that's going to be a 1 over here. And so that is our A. So if we kind of break it apart like that, we have A, and again, x1, x2, x3, x4. Now we need to find A transpose. Now I wonder if I can write that small enough so I can put it on the page here. So A transpose is equal to what? Well, now this row becomes the first column. So we're going to get -1, -1, 0, 0, and then a -700. And then we're going to get what? A 0, a 0, a -1, a -1, and then a -900. And then we're going to get 1, 0, 1, 0, 500. And then we're going to get 0, 1, 0, 1,000. If I can write it properly. And let's go ahead and put our thing here. And then we'll have what? Looks like a 6, a 5, a 4, an 8, and a 1. And so then that's our A transpose. All right, so now from A transpose, what we can do is we can write our dual problem. So now, remember, this is now instead of the x's, these are our y's. And so this is y1, y2, y3, and y4. So we'll have a -y1 plus y3 less than or equal to 6, and so on. So now let's write the dual problem based on that. All right, so we're going to maximize P equals. Now going off that bottom row, this is what we're going to have. We're going to have a -700 y1 -900 y2. And then we had plus 500 y3 and plus 1,000 y4. And that was subject to. And so then we said as -y1 plus y3 less than or equal to 6. Then we had a -y1 plus y4 less than or equal to 5. And then we had a y2 that was a negative plus y3 less than or equal to 4. We had a -y2 plus y4 less than or equal to 8. And everything's going to be less or greater than equal to 0. So we're just going to leave that. So really our y1, y2, y3, and y4. So all of those are going to be greater than equal to 0. So that's our dual problem. Now, that's the inequality system. That's the I system. So now we have to convert that to the E system. A lot of stuff to do and remember here. All right, so when we're doing that, now we're going to go back in and our slack variables are going to go back to our x's. And so remember that our slack are going to be x's. So now we're going to have what? This will go on the bottom. So we'll have a -y1 plus y3 plus x1 equals 6, and a -y1 plus y4 plus x2 equals 5. -y2 plus y3 plus x3 equals 4, -y2 plus y4 plus x4 equals 8. Going back with that one, now we have 700y1. And because remember, we're taking it to the other side, it's positive, plus 900y2 minus 500y3 minus 1000y4 plus p equals 0. Okay. So this is, because we have those are negative here, they become positive when you take them to that other side. All right, so I think that gives us what we need there. Now we have to make our initial tableau with that. Now remember, we're going to have four y's, four x's, and our p, and then we're going to have all the x's down to start with. So this is going to probably be one piece per page, depending on how small I write and stuff. So, coming over here, we'll have y1, y2, y3, y4, x1, x2, x3, x4, p, and then we'll have over here x1, x2, x3, x4, and p. So maybe we can get two per page if I write small enough. All right. Now, putting everything into the right places, we should have a -1, a 0, a 1, a 0, a 1, and then all the rest of those will be 0, and then we have our 6. Then we had a -1, a 0, 0, then we had a 1, and then it had a 0, 1, 0, 0, 0, and then I think that was a 5. Then we had a 0, -1, 1, then 0, 0. X2 is 0, so that was 1, then 0, 0, and then a 4. And then we had a 0, -1, 0, 1, 0, 0, 0, then that was a 1, and that was 0. Then we had 8. Now we had our pluses, so plus 700, plus 900, minus 500, minus 1000, and then 0, 0, 0, 0, 1, and then a 0. All right, so let's start marking this up. Well, that's going to be our biggest negative. And so we can't have this one to be in here because those are zeros. So now we have 5 and we have 8. So our quotients are going to be 5 divided by 1, which is 5, and 8 divided by 1, which is 8. That's the smallest. So our pivot element is going to be right here. Okay. So that makes it easy because that's already a 1. Those two are already 0. So now we just have to take a minus row 2 plus row 4 goes to the new row 4. And we have to take 1,000 row 2 plus row 5. And that's our new row 5. Okay. So that's not too hard. All right. So now let's go. And so this is going to enter. And this one is going to exit. So that means we're going to have on the side x1 and then a y, that's 4. And then we're going to have x3, x4, p. And then we have y1, y2, y3, y4, x1, x2, x3, x4, and then a p. And so then I have that. So the first row stays the same, -1, 0, 1, a 0, a 1, 0, 0, 0, 0, 6. Next row stays the same, -1, 0, 0, 1, 0, 1, 0, 0, 0, 5. The next row stays the same, 0, -1, 1, 0, 0, 0, 1, 0, 0, 4. Now minus this row plus that row. All right, so now we're at the new stuff. So that's going to be a 1. That's going to be a -1. That's going to be a 0. That's going to be a 0. That's going to be a 0. That's going to be a -1. Then it's going to be a 0. Then it's going to be a 1. It's going to be a 0. And that's going to be a 3. Okay. Now 1,000 times that. So that's going to be a -300. That one's going to be 900. That one's going to be -500. That's going to be a zero, a zero. It's going to be 1,000. It's going to be a zero, zero, a one. And that's going to be what, 5,000? Okay. All right. So what is the smallest? Well, it looks like that one's the smallest. And again, that's zero, that's zero. So our quotients are just going to be the top one, which is 6 divided by 1, which is 6. And maybe better write all of it so that when we have it here, so where is that at? Divided by 1 equals 6. And then it's going to be this one, which is 4 divided by 1, which is 4. And so that one is the smallest. And so that's on this row here. So that one's going to be our pivot point. And if that's our pivot, then we're going to say, okay, well, we're just going to say a minus row 3 plus row 1 goes to our new row 1. And here it looks like we have 500 row 3 plus row 5 goes to our new row 5. All right, so I think that's all good. So basically, first row is going to change and the last row is going to change. So let's change our color in here. So we go down to the next row. We better which ones are entering and exiting. So Y3 enters and X3 exits. So it's X1, Y4, Y3. All right. So we're going to have X1, then we had Y4, Y3, X4, and then we had our P, and we had Y1, Y2, Y3, Y4, X1, X2, X3, X4, P, and we have that. And so if we do that, minus that plus that, it's going to be minus 1. Then we'll have a 1, a 0, a 0, a 1, a 0, a minus 1, 0, 0, and then that should be 2. The next row, I think, is the same. So minus 1, 0, 0, 1, 0, 1, 0, 0, 0, 5. Next row is the same 0, minus 1, 1, 0, 0, 0, 1, 0, 0, 4. Uh, then that one stays the same too. So it's a 1, minus 1, 0, 0, 0, minus 1, 0, 1, 0, 3. And then we're taking that 500 times that row plus that row. So that goes to what? Minus 300. That's going to be a positive 400. Then 0, 0, 0, 1,000, 500, a 0, a 1, and that adds up to 7,000. All right, so now what do we have? Well, it looks like our biggest negative now is here. Well, guess what? That's a zero, that's that. So it has to be that one. So we don't have to do any quotients. We know that that's going to be our pivot. All right. So with that being our pivot, what do we have to do? Well, we're going to have to take row 4 plus row 1 is new row 1. We have to take row 4 plus row 2. That's our new row 2. And we're going to have to take 300 row 4 plus row 5. And that's our new row 5. All right. Hopefully we're getting close to the end here. So now let's see here. What do we have? Well, I guess I left it that color, so we'll just keep it that color. So this one enters, this one exits. So we're gonna have what? Looks like X1, Y4, Y3, Y1. So do I have all that right? 1, 2, 3, 4, 1, 2, 3, 4. So X1 stays up there. Looks good. Then we have a P. And then we have Y1, Y2, Y3, Y4. Then we have X1, X2, X3, X4, P. My great straight lines. All right, so my that plus that, so that's going to give us a 0. Then we have a 0, and then a 0, and a 0, and a 1, and minus 1, minus 1, 1, 0, 5. And then add that to that, we get what? 0 minus 1, 0, 1, 0, 0, 0, 1, 0, 8. That one stays the same. So 0 minus 1, 1. And then we have three zeros. And then we have a 1 and 0, 0. And then a 4. That row stays the same. 1 minus 1, three zeros. Minus 1, 0, 1, 0, 3. And then 300 times that plus that. So it's a 0, 100, 0, 0, 0, 700, 500, 300, 1, and that's going to be 900, so 7,900. Yay! All of those are positive, so we can stop. And so that means our min cost is going to be what? $7,900. And it's going to be when what? X1 is 0. And that's again from A to outlet 1. X2 is going to be 700. That's from A to outlet 2. X3 is equal to what? 500. That's from B to outlet 1. And X4 is equal to 300. And that's from B to outlet 2. So these are the number of computers shipped from A to 1, A to 2, B to 1, and B to 2. So that looks to be our solution to that one. So again, nothing hard. It just takes a lot of following along, converting, everything from words to, equations, inequalities, and then getting our dual problem, and then getting our tableau, and then following along and making sure you do all the steps to get to our final solution. Hopefully that helps.